Alrighty, welcome back. So today we're going to be having a look at solving equations with indices. So we're going to need to make sure we remember our index laws, and then basically apart from that we're just going to be having a little bit of fun with using our different indices laws. So the first one says we have 125 to the a equals 25 to the 2. Alrighty, well 125 and 25 are both better written as 5 to the 3. That's 125. And for 25, well, that's better written as 5 squared. Noticing I'm putting in parentheses, that just keeps order of operations proper. Now, using our first index law that we might want to use, a to the m to the power of n is just a to the m times n. So in this case, this can become 5 to the 3 times a, and this one can be 5 to the 2 times 2. Alrighty, 3 times a is just 3a, and 2 times 2 is 4. Well, this tells me, since the bases are the same, then the only way that this can be true is then if the indices are the same. So this tells us that 3a must be equal to 4. And the only way that's going to be possible, divide both sides by 3, is if a is equal to 4/3. So this is probably the easiest way of solving an equation like the one at the top here. The easiest thing to do is to get the bases to look the same. Okay? So in that case, we wanted them both to look like 5 to the something. Let's have a look at the second one. The second one's got a square root, so we're going to have to deal with that. But we've got 49 to the 3, take the square root, equals 7 to the power of b. Well, some of you might know that 49 is just 7 squared. So this is really the square root of 7 squared to the power of 3 is equal to 7b. Nothing we can really do on the right-hand side. It's already got a prime number as its base. So we're just going to have to leave 7b alone. Now for this second part here, well, I can use the same rule I used before to deal with the inside of the root. So that's going to be 7, 2 times 3. So that's going to be 7 to the 6. Take the square root, equals 7b. Except now we run into a problem. I'm going to have to deal with this square root symbol. So let's remind ourselves of the next rule, that a to the m on n is equivalent to a to the m, take the nth root, or the nth root of a to the power of m. Notice n is always the power of the root. Now just as a reminder, there's an imaginary 2 that lives right here. So n in this case would be 2 and m would be 6. So this would be 7 to the 6 on 2 is equal to 7 to the b. 7 to the 6 on 2 is just 7 to the 3. 7 to 3 equals 7 to the b. Well, since the bases match, therefore the indices must also match, which tells us that 3 is equal to b. And there we go, solved the second one as well. So the last one we've got to look at is C. This one's a little bit more complicated. Alrighty, this last one looks pretty intimidating, but we can just keep using the rules we've been using. So we've got our bases are currently 8, 4, and 2. So what we want to do is get them all to be the same. And the easiest way to do that is get them all to look like 2. So let's do that. So that's 2 to the 3 for 8. That's 2 to the 3 to the 2x times, same thing for then 4, except it's going to be 2 squared to the 3x minus 3 equals the square root of 2 to the 3. Just to make my life a bit easier, I'm going to rewrite that using the root rule again. So it's going to be 2 to the 3 on 2, m on n, 3 on 2. Alrighty. So now let's really focus on the left-hand side. The right-hand side really can't nothing be done yet, so let's just focus on the left-hand side. So 2 to the 3 to the power of 2x, well that uses the multiplication rule, so 2 to the 3 times 2x times, and same thing for the next one. It's going to be 2 times and then 3x minus 3 equals 2 to the 3 on 2. Can't touch the right-hand side just yet. Let's simplify each of these indices. So we're going to get 2 to the 6x times 2 to the, expand the brackets, is going to be 6x minus 6 equals 2 to the 3 on 2. Now, at this point, I'm going to have to combine these two together, because the only way the rule worked previously was because I had this only one base on each side. So I'm going to need to combine them. And the only way to combine them is using another index law. So a to the m times a to the n. If the bases are the same and you're multiplying, then you can add the powers together. So let's do that. So this is going to give us 6x plus 6x minus 6 equals 2 to the 3 on 2, which is 2 to the 12x minus 6 after collecting some like terms. And now we've got it exactly as we want it. The bases match, therefore the powers have to match. So we get 12x minus 6 is equal to 3 on 2. There's a few ways I could go from this. Let's just directly solve it. So add 6 to both sides. 12x equals 3 on 2 plus 6. Well, 6 is better written as 12 on 2. 12x is then equal to 15 on 2. Divide both sides by 12. And we get 15 on 2 times 1 on 12, which is 15 on 24, both of which are multiples of 3. So it's 5 on 8. And there is my solution to that third one as well. Alrighty, so 3 different ones. The first 2 of not too bad, and that third one just taking a little bit of work to simplify and get everything to work. Alrighty, I'll see you in the next one. Goodbye.